So this is about net change using integrals. So if you remember, we're taking the integral of our function gives us our antiderivative, meaning that's our derivative and that's the antiderivative. So what it's giving us is actually the net change. By plugging in b and a into our function, it's giving us our net change. Let's take a look at it and see why. So the marginal cost of producing a certain commodity is this, dollars per unit when Q units are being produced. So now if we take the integral of our derivative, right, with respect to Q, it's going to take us back to our cost function. So what we're getting is C of something minus C of something. So now we want the first 10 units. So we're going from 0 to 10. So that would end up giving us C of 10 minus C of 0. That's what it's saying. So this is our net change, our actual change in cost, or the total cost of producing the first 10 units. So let's try and do it. So we have integral of 0 to 10 of 6Q plus 1 dq. So this would be 6 over 2 q squared plus q, and then we plug in 10 and 0. So what does this give us? So that would be 3 times 10 squared plus 10, and then minus, and they're both q, so they're both going to give us 0. So there's no reason to subtract that. So this gives us $310. Where am I getting dollars? Because it says this is dollars per unit. So our C prime, right, is in the change in C over change in Q. And so that's dollars per unit, meaning our cost is in dollars and our Q is in units. It also says Q units. So the actual cost of producing 10 units, $310. Okay, so now it says what is the total cost of producing the next 10 units? So that would be from 10 to 20. So you got to think about integrals as what they are. So we have our cost function, which is linear. You can see it's got a slope of 6q1. So we have this cost function, and we're going from 0 to 10. So that area under the curve, this is our total cost of 0 to 10. Now if we continue it and we go to 20, like that, then this in green would be the cost of producing the next 10. So integral from 10 to 20 of 6q plus 1 dq equals, and then again we get the same exact thing, so 3q squared plus q, 20 to 10. See, now when we plug them in, you'll probably see it a little bit better now. So that's the total cost, if you think about it, of producing 20 units, right? Minus the total cost of producing 10. Now, what we're doing here is we're plugging it in. So if you think if there was some constant sitting there, that constant would be here, and they're both being subtracted away. So what does this give us? We already know that that's 310. So the cost up to 10 units is 310. And so now we can think about it as the cost up to 20 units. So that's 1220. And so we end up getting $910. So $910 is how much it's going to cost to produce the next 10 units. So by taking the marginal cost, taking the integral and plugging in the two numbers, it's taking us back to the total cost function without the constant, of course. And then we can plug in 20 and 10 to find the difference in the two, giving us our net change. So the total cost of producing the next 10 units would be $910. You can also think about what it's doing here. And what we are thinking about is you're talking about all these little rectangles being added up, right? And so you can kind of think of it as that it's summing all of these costs for each of these units all the way across, and then it's adding them up. And so it's telling us the cost from 10 to 20. It's taking and adding up all the costs that we get to get the 910. However you want to look at it, net change.